Some absolute value equations have two absolute value expressions in them. So when you have something in the form of absolute value of x equal to the absolute value of y, you can rewrite it as a compound equation where x equals y or x equals negative y. Or you can make the x positive and negative, just that one of them is positive, one of them changes sign. So we can have x equals positive y, x equals negative y, or y equals positive x, y equals negative x. Either way. So for instance, I have the absolute value of 2x minus 3 equals 4x plus 9. Here's the graph of those two equations. And you can see they cross right here when x is negative 1 and also when x is negative 6. So I know when x is negative 1 and x equals negative 6 are my two answers. Let's try to figure this out algebraically. So what we do is we have this 2x minus 3 equal to the absolute value of 4x plus 9. I just remove the absolute values. So 2x minus, try that again. I have 2x minus 3 equal to 4x plus 9. But I'm also going to have 2x minus 3 equal to the negative of 4x plus 9. For the one on the left, what you can do is you can subtract 2x from both sides. And I'm going to subtract 9 from both sides as well. So you can subtract any amount as long as you do the same amount on both sides. 2x minus 2x is 0. Negative 3 plus a negative 9 is negative 12. The right-hand side, we have 4x minus 2x is 2x. And then if you divide by 2, you'll end up with x equal to negative 6. And that is the one we found here on the far left. For the other one, let's distribute that negative through that 4x plus 9 first. So we have 2x minus 3 is equal to negative 4x minus 9. And so now if I add 3 to both sides and add 4x to both sides, the idea is to get the x's by itself on one side and get the constant, the number part, by itself on the other. What I'll have is 2x plus 4x is 6x. And then minus 4x plus 4x is 0. Minus 9 plus 3 is negative 6. And now if you divide by 6, we end up with x equal to negative 6 divided by 6 is negative 1. And that matches the other answer. X equals negative 1. Let's try another one. Let's say x minus 3 is equal to 5 minus x. So again, just rewrite it without the absolute value. And then write it as without the absolute value on one side and the negative of it on the other side. So x minus 3 is equal to 5 minus x, and x minus 3 equal to negative of 5 minus x. So in this case, on the left, I would add x to both sides. And say add 3 to both sides as well. So I have 2x is equal to 8. And so divide by 2, I get x equal to 4. And that is the absolute value of 4 minus 3 is 1. The absolute value of 5 minus 4 is 1. So that checks. This one, I distribute the negative through. So I have minus 5 plus x. In this case, if I subtract x and add 3, well, x minus x is 0, so that disappears. Minus 3 plus 3 is 0. So I end up with 0 on the left side. Negative 5 plus 3 is negative 2, and x minus x is 0. 0 minus 2 does not have an answer, so there's no solution for that. And I can effectively ignore that part. So there's only one answer here, and that's when x is equal to positive 4. All right, one more. 9x plus 1 equals 6x plus 4. I write it 9x plus 1 equal to 6x plus 4. And then 9x plus 1 equal to the negative of 6x plus 4. The left side, I can subtract 6x from both sides and subtract 1 from both sides. I will have 3x is equal to 3. So divide by 3, I get x equal to 1. The right-hand side, let's distribute that negative through. So we have 9x plus 1 equal to negative 6x minus 4. And then see, subtract 1 from both sides and add 6x to both sides. 9 plus 6x is 15x. 1 minus 1 is 0. Negative 6x plus 6x is 0. And negative 4 minus 1 is negative 5. Now if I divide by 15, I'll have negative 5 divided by 15, or negative 1 over 3.